Okay, great. So welcome to the first showcase. Thank you all for diving in, or if you're watching this later, thank you for watching. This first one will have a little different format to the future ones. Today we'll focus on the Wildlife Watcher only. We'll introduce the project and the roadmap, talk about where we are and how we got here, and finally just what the next steps are from here. But in the future, we will include updates from all projects on this call. I will also welcome questions, but probably towards the end of the session. So please note them down as we go along, and then we can answer them at the end. Okay, let's kick off. So a little bit about the background of the project and what problem we're trying to solve. We've noticed that most of the equipment that exists on the market currently is quite restricted in terms of the triggering mechanism. For example, the thermal imaging alone doesn't capture all the wildlife, like cold-blooded animals, including reptiles, amphibians, and invertebrates. Some small mammals are also not reliably captured. Another issue we've noticed is the delay in processing image. There's often a gap between taking the picture and actually classifying it. This lag means that some decisions might end up being based on outdated information. So what we're proposing is we're currently focusing on developing a new technology that would use a more reliable motion sensor, which could pick up all cold-blooded animals as well as warm-blooded, and have machine learning modules deployable on camera and a way to manage them through a desktop app. And additionally, the team is also developing a mobile app to complete basic camera operations and configurations rather than completing those actions on the camera itself. And finally, real-time notifications will be sent to a user to alert them to a presence of a specific species. And let me just dive in a little bit deeper into project objectives. So largely is what I mentioned already, plus good quality images that we need to capture day and night is the aim, and accurate species identification via the on-camera AI that we're trying to deploy. Efficient battery, obviously, that would enable the camera to stay deployed in the field for extended periods of time, and cost effectiveness. And we want the equipment to be as affordable as possible. So these are our aims. And now a little bit more about the use cases. So the first use case that we are targeting is a gecko, both Moray white and ghost striped. That would be detectable day and night, as well as saving that data on the SD card for now, so that the user can actually process the footage using an external classifying software. Here, the accurate motion sensor, as mentioned before, and image quality and some sort of illumination play a big part, just to be able to tell those species apart and capture footage at night. The project's goal is to understand the distribution, population size, and behaviors in the wild a little bit better. And the second use case is a detection and identification of a rodent. With this one, it's important to have working machine learning models loaded onto the camera so that a user can receive real-time updates when a rat is detected, as the project is all about predator impact and predator control. Decent battery here as well might be important. And after all that, the aim is to optimize the camera design and technology just to make sure that it caters for a large number of cases to support conservation management. And we'll be working with our partners, existing and future, to identify those use cases. In terms of the time frame to achieve this, here's a detailed breakdown of the roadmap divided into hardware and firmware, and then data science and software. On the hardware side, we have things like printed circuit board optimization, motion sensor, triggering system, waterproof camera case, battery and illumination, as well as the firmware that ties it all together. And the software side includes the image storing and processing, mobile and desktop apps, and machine learning models. The plan is to have the prototypes ready for testing with use case number 1, which is the gecko, by end of Q1. So April time. and start testing with use case number 2, the rodent, towards the end of Q2, which is July. And you'll see us referring to those deadlines as MVP. That's a minimum viable product that's required for a particular use case. And the testing will be done by our partners, the environmental and community groups that Victor has been in contact with. Once that's achieved, we'll focus on further optimizing the design, following the feedback that we receive from those organizations, and preparing the cameras for market launch, which is very exciting. We're targeting the end of the year for that. Let's skip one slide. In terms of what we've been up to so far, unfortunately, Charles is on leave and can't provide the update on the amazing work that he's been doing on hardware, but I'll pass on to Victor first to fill in, and then Tobin will take over and talk about the software side. So Victor, over to you. Do you want to share anything, or are you okay to stay on this slide?
I'm happy to talk if it's okay. So quick update on the hardware side of things. Dev probably now has more to say than me. So for anyone who doesn't know Dev, he just recently joined last week. One.ai. And he's going to be helping also with the testing of the camera, and his skills are mostly on the data science side of things. But I think that soon he's realizing the power of making things work in terms of the hardware side of things, and making it easy for people and users to interact with it. So on the hardware side, the biggest challenge that we had with the previous prototype, it was to easily deploy the devices on the field. So we went a few times, Cal here is on my right, we went to the field, and you turn on the cameras and you leave, and then you come back a week later, and then you realize that the SD card wasn't really recording, so you just missed the entire week. And the batteries wasn't, very properly telling you the level of the batteries on the device. So one of the main things, it was for us to be able to develop a system where we can actually test different things on the field. So for that, we needed to have a new PCB, or printed circuit board. And Charles has designed that, has printed that one, and we have 5 working PCBs at the moment. So that's the image on the left, that looks like a lot of electronics bunched together. And at the moment, there is a lot of tedious work of plugging things in and plugging things out, and trying different pieces of software, of hardware. But it is amazing. Like we are able to have that information straight away, whether the camera is working or whether the Bluetooth communications are working or not. So yeah, we are an amazing stage now to be able to test those different timelines and tasks that Carolina mentioned, in terms of the motion sensor and in terms of having good quality images both at day and night. So yeah, that's a big overview of the hardware. For anyone interested, I'm pretty sure Charles will be able to tell you more about it. But yeah, there is really cool stuff for those that are interested in playing around with electronics. There is really cool tech out there, open source available. So we're going to try to make the most out of it. So I'm passing it on to you.
Beautiful. Thanks, Victor. Well covered without Charles' presence here. You did well. And also thanks, KK, for putting everything together. Appreciate your mahi. Cool. So the software. I'll try to keep it on the surface level for how much is going on, but essentially the way it is that we have a big project, and there's a small team that's really putting a lot of hours in to try and connect the dots, understand the systems, and link everything together. I think the biggest thing we're trying to do is give the full solution seamlessly for a user. So trying to have something from start to end point without people needing to know code, without them having to understand the ins and outs of installing software and bouncing between different platforms, which definitely has its challenges because we have a lot of moving parts. We have the mobile app, we're going to have a web, a desktop API, we've got the device itself, which has so many capabilities, and it's hard to find the line of where you have the limits to meet the deliverables that we're trying to produce. So the deliverables on a short perspective is how to keep it super low power, how to, have the SD card just to store some footage, and what level of that do you want? The communication between them, so the Bluetooth, and there's a technology called LoRaWAN, which is long range wide area network, so long ping messages, so the user's able to get real-time notifications on their phone instead of having to go into the wop-wops, into the bush, and pull the device out to be like, okay, was it worth my time or not? No, we can do real-time for notifications. Yeah, there's a lot going on. It's really fun being in a small team because we have to tackle these challenges collectively, and you can't just pass it on to the expert for each piece. You have to figure it out in and amongst ourselves. But we've already made some amazing progress. We have the device and the mobile app already communicating. So we're able to control the device via the mobile app already. That's a big credit to Charles and Miha, who unfortunately are both not here at the moment. But they put a lot of work in the background to get those pieces working, which means we're able to keep developing our firmware, keep working on the database, and just slowly, each piece by piece, as things are progressing in total, instead of one big piece of the software at the moment progressing, all collectively is getting more documented over time, and just to keep on keeping on. So I think I'll stop on there. We can definitely break into it. And if people have questions, if people want to know more or have other ideas for us, I'm definitely keen to hop in calls, hop in email threads, and discuss concepts. So yeah, sing out if you need. Cool. I'll pass it back to you, KK. Oh, no, I'll do questions maybe. Ash?
Oh, just a quick question. I'll probably connect with you a bit later because I don't want to bore everybody with technical questions. In terms of, I think Anton said you guys had issues, that different components weren't working at times and such. So like the Voyager systems, I don't know, they send that aircraft or spacecraft, in the 70s. What they can do is they can turn things on and off. If you have that sort of capabilities where you can save power by turning things on and off, and various sorts of testing, if you kind of build that into your software, you may be able to kind of manage things a lot better. And in terms of the software, are you deploying it via containers and such? But we can chat about that later. You don't have to answer that now.
We can definitely dive in.
The reason I say that, the reason I say that is because that'll make it a lot easier for non-technical people to just run a script and dump stuff to a device, and it works because I've used that for work and it's brilliant. So we can chat about that later if you like.
Yeah, I'd love to hear more of your thoughts on that. Regarding the point one, is we're underway with quite a few different methods to approach how to go ultra low power. So there's technology we're using. We're not reinventing the wheel for some aspects. There's some microcontrollers that are already on the market that have dedicated AI processors. So we're tapping into these. We're working quite closely with the HiMax team. They've got a special chip called the WiseEye 2, which has the support networks we need. So for instance, motion detection cameras, it's already got support for that. It's got support for the AI modules, so it doesn't chew up extra processing time unnecessarily. And then, there's other various components within the device itself that will definitely we're going to be trying to have the device pretty much completely powered down 98% of the time, unless it, one, gets some motion detection, and then two, if the onboard AI model gets a ping, so like if it's over a threshold for its object detection, it'll then say, okay, cool, start recording, start tracking, start processing whatever we're needing to go from there. So I'd be keen for you to follow up with me afterwards, though. I want to hear more about your second point. So.
Great. Thank you for that, Tobin and Victor, and thanks, Ash, for the question. I might move on to the next slide. So we have nothing to really demo. It's just
Can
a
I have a
global update.
question? Can I have a question on the stuff here? Yeah, thanks.
Sorry, who was that?
Have you considered the Halo chip that comes with Raspberry Pi? They have a nice AI kit.
I'm aware of it. We have discussed it. We've gone through about 5 or 6 different microcontrollers that we have looked at. I'm aware of Halo, but don't know the ins and outs of it. So maybe that's something you could just flick me some info if it's worth it. But we have also done quite a bit of testing for what the features we want and the deliverables to be on the device. And the current one we have, we've engineered into on your screen that hardware chip that is on the left, the left image. I think we're at a point on this device that we'll be sticking to the componentry we have because we are pretty invested in the development for that. But
sure.
feel free to pass pieces on if there's something that might add value to us for sure.
All right.
Sorry, are there any more raised hands? Because I actually can't see raised hands. I can just see a broken image. Any more questions? No? Okay, great. So I can move on. Okay, so as for the team that's involved in this beautiful work, we have the core technical teams of Charles, Tobin, and Dev. Dev, as Victor said, has only just started, but is already doing an incredible job. Our amazing data rangers, Miha, that's responsible for the mobile app, Shri and Raj working on the back end. We have our lovely UX experts, Kyle and Aggie. And then we have 2 new data rangers as well. We have Fraser and Tim. Fraser is here to help with the back end, and Tim is here to help with the embedded devices work. So welcome on board. They're both based in the US, so I doubt they are on the call. But let's welcome them when they join Slack. And of course, there's Victor and I. Victor is steering the ship, and I'm helping out. Great. Now, so this is just Wildlife Watcher team. Just to be clear, this is not Wildlife.ai team, Wildlife Watcher team. There is more of us in Wildlife.ai. In terms of the next steps, so what we'll be focusing on is, I think Victor mentioned that already as well, testing of the cameras with the new single printed circuit board that Charles created in different conditions and different scenarios, testing the battery, the illumination, and the image quality out in the field. And that will be Dev's main focus, that and the exchangeable image file format for the saved footage as well. Connectivity between the mobile app and the SD card, as Tobin mentioned. So essentially transfer of the deployment data between the camera and the phone to make sure that the relevant information is available in the right format, which Tobin and Miha will most likely focus on, and continuing to optimize the database, test available APIs, and progress the build of the starting and ending of the deployment flows in the mobile app, which will be mainly Miha, Shri, Raj, and Fraser as well. And finally, are there any more questions? No more questions? Anything to add, Victor?
Yeah, great job. I think it was awesome to have an update for the rest of the team also. Yeah, as Tobin mentioned, there's a lot of mahi that was going on to it. Yeah, always open to hear everyone's thoughts and suggestions. Yeah, I love it. Thank you for putting it together, and KK, much appreciated.
Kalindi, there was a question.
Hi, yeah, I have a few questions. I don't know, maybe I missed it in that first minute when I was trying to get my chat to work. maybe what's the like motivation of this project, like the wider context, and then also what are the like big goals, like maybe like same as context, but in the future context.
Yeah, so you might have missed it. Yes, we had the overview
Okay, then
of
I'll
the
just
problem and
look
the
at it.
solution. And
Yeah,
then,
yeah.
yes, I'll send you the recording so you can go through it in your own time. But I'll also send out this presentation for everyone, just for context. Any more questions? So like I mentioned, this type of thing, so showcases will be a monthly occurrence. In the future, we'll have more projects participating. For now, we just focus on Wildlife Watcher because it was very short notice, but in February, we'll be actually giving an update on, can you hear me?
Yeah.
Okay. We'll be focusing on all of the projects at wildlife.ai in the future. Perfect. Thank you so much, everyone, for dialing in. And like I said, you're getting half an hour back at least. And enjoy your evening, your day, or your afternoon.
Thank you, everyone.
See ya.
Thank you.
See you.
Thanks, guys. See you later. Bye.
Thank you. Bye.
Another that box size again, or is it?
It will be a different box this time.
100 questions now because.
Yeah,
I
Yeah.
think it will still be a 3D print, right?
yeah.
Yeah, but probably just smaller modified.
Oh, really?
Yeah.
Same to see that today, like with the wooden ones at the bottom and the things that draw the.
We could probably, yeah, we could probably, yeah, depending on